because of time, we are actually going to just do a recap of what we have been doing in before. So fire is responsible for a lot of things, and death is one of the things that fire results in. If you look at the example for Minnesota in 2010, there were 14,561 fire reported. And apart from the death, there are 137 reported civilian injury, while 152 million in property damage. Most of us always feel our houses are the place that is safe for us. However, we can see that 70%, 76% of all structural fire occur in residential homes, while 97% of structural fire deaths occur also in residential property. So what causes fire? Based on studies, the top 5 causes of fire include cooking, open flame, eating, incendiary or arson, smoking. Those are the things that are responsible for fire. So from there, we go to fire science. For fire to start, there are 3 things. There are things that will make fire to start. That is what we call what are the things that will make fire to start. So let's look at them one after the other. Let's look at it one after the other. The fire tetrahedron combines all the elements that will make fire to occur. The fire tetrahedron combines all the things that will make fire to occur. So for fire to occur, you will need the heat must be available, oxygen must also be available, fuel must also be available. These 3 will join together via a chemical reaction for fire to occur. So what can be the fuel? What can be the fuel? The fuel can either be liquid, so the liquid can either be, the fuel can either be liquid, solid, or gases. So example of liquid could be grease, could be oil, could be fuel, gasoline, etc. For solid, it could be wood, it could be paper, and it could also be melter. For gases, it could be natural gas, propane, acetylene, or any other gas. So when we now look at that, we now look at the classes of fire that we have. The classes of fire that we have. We have class A fire, which are also called ordinary combustible. Class A fire are also called ordinary combustible, such as wood, paper, clothes. Those are class A fire. Class A fire are ordinary combustible. Class B are flammable liquid, such as oil, grease. Those are class B fire. Class C are energized electrical equipment. Class C are energized electrical equipment, while Class D are flammable metals. Class D are flammable metals. We will add some more of the classes when we get to, but these are just preliminary for us. So we said fire are always accompanied with many things. One of the things that accompany fire is smoke. One of the things that accompany fire is smoke. So what is smoke? Smoke is a collection of airborne solid or liquid particles and gases emitted when the material undergo combustion or pyrolysis. Smoke is the collection of airborne solid and liquid particles and gases emitted when a material undergo combustion or pyrolysis. That is what we call smoke. So, when fire burns, when things burn, it causes fire. But there are two different types of burning that occur. There is what we call combustible and there's what we call flammable. There's combustible material and there are what we call flammable material. So combustible materials are materials that has a flash point of 100 degrees Fahrenheit or above. Combustible materials are materials that has a flash point of 100 degrees Fahrenheit, or while flammable material has a flash point below 100 degrees Fahrenheit. That is the difference between a combustible and a flammable. So when fire occurs, we always feel that the only thing that we see is the flame or the smoke. However, when fire occurs, there are other gases or other things that accompany fire. Carbon particle, sulfur dioxide, water vapor, carbon monoxide, hydrogen cyanide, light, smoke, heat. Those are the things that always accompany fire. So we know that for fire to occur, we need the tetrahedron of fire, which means the three elements of fire, which is fuel, the heat, and the oxygen, must combine together. The fuel, the heat, and the oxygen must combine together to form what? To form the fire tetrahedron through a chemical reaction. That is when the fire occurs. But when that fire occurs, how does it burn? How does fire burn? That takes us to the phases by which fire burns. The phases by which fire burns. So the phases at which fire burns also depends on the time the fire is burning, the kind of air that within that environment, that means the ventilation characteristics of the confined structure, the amount and the type of combustible material present. What are the things that is burning also determine the phase at which the fire burns. If you put a metal down and you put paper down and you light the two, it will take few minutes for what? For the paper to what? To ignite. Why it will take a longer time for what? For the metal to what? To burn. If you take paper and you take wood down, Paper will burn quickly and will get off easily, while wood will also start burning, but it will take a longer period to burn. So that is why they said it depends on the amount and the type of combustible materials that is burning. So for burning, there are three basic stages of burning. There are three basic stages of burning. There's what you call incipient or beginning phase. There's what you call free burning phase, and that's what you call smoldering phase. Three basic progress of burning. There's incipient or beginning phase, there's free burning phase, and there's what we call smoldering phase. So at the incipient stage, oxygen is very rich. At the incipient stage, oxygen is very rich. So the fire has just started and the burning progress very, very rapid. At the incipient stage, oxygen is plentiful. Temperature has not really built up. Breathing may not be difficult. And with a little fire extinguisher, you can quickly extinguish the fire. That is at the incipient of the beginning phase. The next one is the free burning phase. The next one is the free burning phase. At the free burning phase, the fire has evolved or has engulfed more of fuel. Now the fire has what? Has more power. The fire has more power, and oxygen supply is already what? Depleting. The oxygen supply is depleting. However, it has what? Accumulated at the place. It has accumulated at the place. The last stage is what we call the smoldering phase. The last stage is the smoldering phase. At the smoldering phase, oxygen supply is not equal to the demand of fire, and the temperature throughout the building is very, very high. Now, oxygen depletion may cause backdraft. The fire may be burning off and on. Fire extinguishing method becomes more difficult, and ventilation, breathing and ventilation becomes difficult because a lot of smoke has been fully developed. So from there, that's what we now discuss what's called mode of spread of fire. How do fire spread? A fire will start at one end of a building, and within a few minutes, it gets what? It gets to the all part of the building. So how do fire spread? Fire spread through three different means, either by conduction, convection, or by radiation. Conduction, convection, and radiation. Conduction occur only in solid. Conduction occur only in solid, while convection occur in liquid and in gases, while in radiation, the heat is radiated from an hot object, but it goes into different media or medium. It's neither conduction nor convection. These are heated rays emitted from a hot object. So let me explain what convection is. If you light a candle and you hold a spoon, you put one end of the spoon on the candle. After some minutes, you will drop the spoon. Why? Because the heat has transferred from one part of the candle that you are having contact with the candle, of the spoon that's having contact with the candle, to what? To the other end. That is conduction, because it is passing through that metal. Convection is when it occurs both through liquid or gases. It passes through both liquid and what? And gases. So in conduction, heat energy is passed on from one molecule to the next. The molecule vibrates above its mean position, The ability to conduct it varies between the materials. That is the example of conduction. While convection, when a liquid or a gas is heated, it expands, it becomes less dense, and what? It irradiates it and it transfers to it. For radiation, it does not involve any contact. It doesn't have to involve any contact. If you put a laser, you on a laser like a torch. If you on a torch and you put it on a white paper, even the torch turning the white touching it or not, it's just the ray to touch the white paper. After some times, you find out that the portion at which the ray is pointed to becomes heated, and some minutes it will what? It will burn off. That is radiation. So now let's look at combustion. Let's look at combustion. There are 4 types of combustion. There are slow and incipient combustion. There is rapid or active combustion. There is deflagration, and there is explosion. There is slow or incipient combustion. There is rapid or active combustion. There is deflagration, and there is what? Explosion. Slow and incipient combustion, in which the amount of heat and light emitted is feeble, just small, like you are burning small thing. Rapid or active combustion, in which the considerable amount of heat and light emitted within a very short time. Deflagration takes place within a considerable rapid heat involving light, while explosion what? Involve loud noise within an extremely short time when it is what? Generated. Rate of combustion. What are the things that contributes to combustion? The area of contact with air, the amount of heat generated, the ability of the material to conduct it itself, the atmospheric humidity, the wind temperature, the wind velocity temperature, or atmospheric pressure. So for hello, Mr. Osborne, please mute your. You're causing a feedback here. So, if you know that during dry season, fire burn more during dry season than during wet season. Why? Because the atmospheric humidity is very low. The air is already dry, and the wind is always higher during dry season. So that's what? That contributes more to combustion. So the rate of combustion or spread of fire would depend on the area of solid or liquid in contact, the amount of heat generated or to rise the temperature, the ability of the material to conduct heat, the atmospheric humidity, the wind velocity, the temperature, or the what? Atmospheric pressure. Those are the rate of. Let's stop there and let's go to the next lecture. Let's stop there and go to lecture 2. It's just a revised class. So we now have, because we just have 40 minutes. So fire prevention and control. Fire prevention and control. Why do we need to prevent fire, and why do we need to control fire? We need to prevent fire and control fire because fire causes a lot of what? Damage. Fire causes a lot of damage. The consequences of fire include loss of life, loss of friends or family. It can cause injury or disability. It might make us to lose our home, our workplace, also loss of income or job. When sometimes we lose things that are irreplaceable. If people die as a result of fire, you can't replace human being. You can't replace human being. So when you can't replace human being, it is. Sometimes there are also what to call financial loss. There are also what to call financial loss. So how do you prevent fire? Fire prevention protection include procedure for preventing, detecting, and what? Extinguishing fire. Before you can protect a place for fire incident, what will you do? You must first put in preventive devices, or you detect the fire. Then after, you do what? You extinguish the fire. So for a place that wants to put fire machinery in place, you start that at what? At the beginning of the designing of the building. At the beginning of the designing of the building, that is what you do. What? You plan about the protection of the fire. You want to design your house, and you are saying the material that your architects must use must be what? Wood. Everything wood. I don't want any block. I want my house to be this. Are you making preparation for the thing that will counter the wood? Because if there's any small fire, there's probability that that building will engulf in flame, unlike a building that is with block. The fire can easily spread in a wood building than in a block building. So carefully plan and periodically carry out fire drills. Also, you must make people to be aware about fire. Their knowledge about fire is very, very important. So some of the fire prevention activities include regular scheduled through inspection of all fire protection equipment. Some people, they will have fire extinguisher in the office, they will not check it. It is after, when the fire incident occurred, they now go there and pick the fire extinguisher. They just say the fire extinguisher is not working or it has not been serviced. It's because they did not They did not check the thing. So it is important for us to inspect and also communicate. Once fire has been detected and there's potential that fire will be very bad, you need to raise an alarm for all the occupants to and as well you mobilize fire protection forces to come in and do it. For every places, there must be what you call fire. There must be what you call emergency procedure. What are the emergency procedure in place? For building evacuation, you must have an assembly point. You must provide information to emergency crew about the reason for evacuation when they arrive. So what are the basic fire prevention tips? Be mindful of fire safety. Don't block any exits or call points or any extinguisher. Make your company a no smoking policy. If you want to smoke, designate a place outside where smoking can occur. Take care of any hot process that could lead to fire. Maintain all machineries. Observe good security in case there could be arson or people may deliberately want to come and set fire into a property. Don't wedge fire door. Never use anything to obstruct fire door. So, and it is important for us to know that if you don't have knowledge about fire, don't try to fight fire yourself. If you don't have any knowledge about fire, don't try to fight fire yourself. Always raise an alarm, call for fire service, and inform them about the fire. That's lecture 2. Let's do for lecture 3. Lecture 3 is the use of fire extinguisher. The use of fire extinguisher. Understand the combustion process and different fire classes. Understand the fire extinguisher use, operating the procedure of operating a fire extinguisher. So what are the fire classes that we talked about the other time? I said there is class A fire, there is class B, class C, and class what? D. Class A fire are just what we call ordinary or combustible material, which are what? Trash, wood, or paper. While class B fire are liquid or greases, including gasoline, oil, or other solvent. Class C are electrical components, computer, fax machine, energized electrical material, while class D are combustible metal. Another class is called class what? K. Another class is called class K, or some other country call it class F. You can either be class K or class F. This involve combustible oil, fat oil, or cooking oil. They have been classified as class K or class F, depending on the country. So let's look at the anatomy of a fire extinguisher. The anatomy of a fire extinguisher. What makes up a fire extinguisher? What makes up what? A fire extinguisher. So the first thing, I don't know if you can see my cursor, is the fire gauge. The first thing is what they call what? The fire gauge. Is the pressure gauge. It is very, very important. That is the first thing you must check for in a fire extinguisher. It is the gauge that will determine whether the fire extinguisher has content in it. If you open a fire extinguisher, you don't check the gauge and you start pressing and there's nothing. So immediately you carry a fire extinguisher, the first thing you must check is the pressure gauge. The second thing is what? The discharge or lock pin. There's a discharge or lock pin that always keep the content in. The next one is the discharge lever. The third one is the carrying handle. We have the discharge hose. We have the discharge nozzle. We have the discharge orifice, and also the body of the fire extinguisher. The last one, which is also very, very important, is the data plate. The last one is the data plate. The data plate is where they put all the necessary information about the fire extinguisher. There they'll tell you the class of fire that particular fire extinguisher can extinguish. They tell you the class of fire that particular fire extinguisher can extinguish. So, and based on that, there are different types of fire extinguisher. There's what you call pressurized water, which are for class A fire, just ordinary combustible fire. There's what you call carbon dioxide fire extinguisher, which is normally referred to as CO2. That's class A. The pressurized water is normally used for class A fire, while the CO2 can be used for class B or class C. There's another set of fire extinguisher called multipurpose dry chemical. Multipurpose dry chemical, which can be used for class A, class B, or class C. Can be used for class A or class B or class C. So when you hear fire, there is an acronym we normally use. We call RACE. rescue, alarm, contain, and extinguish. When there is fire, the first thing you plan for is to what? Rescue, raise an alarm, contain it, then before you extinguish. Don't say, let me put out the fire before you go and start saving people. No, the first thing is rescue, alarm, contain, and what? Extinguish. So how do you use a fire extinguisher? How do you use the fire extinguisher? I told you that by the time before we go for our exam, or even after our exam, we are going to do a practical section where we go to Lagos State Fire Service and do the actual practical there. But you can do, for you to use a simple fire extinguisher, there's an acronym by which we use. We call it PULL. They call it what? We call it PASS. PASS. Pull the pin, aim low at the base of the fire, squeeze the handle, and what? Sweep. Sweep. That is the acronym we use. So we have less than 10 minutes. If we finish, if the Zoom class finish, if we want to continue, we can use our WhatsApp. So somebody can help us to set up the WhatsApp call, and we use it to continue the class. So the next lecture is fire protection in building. Fire protection in what? In building. So in the first lecture, we heard that most of the fire incidents that occur normally occur in buildings. So if fire occurs inside building, how do we prevent it? So to prevent it, there are various means by which you can prevent fire from occurring in building. The first one is the legislative requirement. The second one is the construction preventive and protective measure. The third one is the means of escape, putting a fire detection or alarm system, means of fighting or suppressing the fire, and access to what? To the fire. Access to what? To the fire. So for a building, there are different classes of building. There are three major different classes of building. There's class A, class B, and class C. The class A are buildings that are what? Complete non-combustible construction. Complete non-combustible what? Construction. That means they are made up of materials that are not easily burned. Block, metal, fiberglass, those are class A building. Class B building include traditional construction. That means non-combustible wall, but sometimes they have combustible floor. The wall may be non-combustible, but the floor will be what? Combustible. They can use wood as the flooring. While class C are combustible construction. Everything are made of what? Things that can burn. Everything are made from things that can burn. So for construction, preventive and protective measure, we will talk about elements of structure, compartmentalization, and the inner lining. The element of structure defines as the part of the material that is used to build the main building. So what makes up the structure of the building? The frame, the beam, the column. You know, if you come to the most part of VI now, you see that most of the building now, you see that metals, iron steel, very big iron steel are the thing that are used as what? Element of structure. Unlike in the olden days, whereby it is block that are used as the element of structure. Now, metals are used as the element of structure. The next one is compartmentalization. What do you use to separate the building from one another? What do you use to separate the building from one another? Also, what are the lining put in place? What are the lining put in place? What are the lining put in place? What are the lining they use? You look at nowadays, most of us use what? POP. Some people use POP on the wall. All these things are things that call internal lining, and they always contribute to what? To fire. If you read the material, you see the example that I gave there. The next one is means of escape. Means of escape. What is means of escape? Means of escape is defined as the approved document as a structural means by which somebody or anybody can escape a property in case there is what? There is fire. So for you to determine the means of escape, what are the factors to put into consideration? What is the excavation time? What is the excavation procedure? What is the occupancy? What is the travel distance? What is the escape route? The route that which the person, are there emergency light signal or means of detection, giving warning or suppressing the fire? Also, this also determines, what determines the means of escape is evacuation time. So for you to determine the evacuation time of a building, when did the fire detect? Who sound the alarm? Occupants should be able to recognize the alarm, and occupants should be able to respond to the alarm. What is the time it will take to evacuate everybody out of the place? So for a Class A building, the evacuation time is 3 minutes. For Class B building, the evacuation time is 2.5 minutes. For Class C, the evacuation time is what? 2 minutes. So I've given you different examples of single escape for different category of building. For a residential institution where like a care home, the door and the means of escape must be what? Between 9 to 18 meters. For hospital, 15 to 30 meters. For hotel, 18 to 35 meters. For school, 15 to 32 meters. So the exit that a building must have also determine on the number of people that are available. So if between 1 to 60 people are in a place, we can still put one exit. If between 1 to 600 people, 2 exits. Between 600, there will be what? 3 exits. So how wide should the door be? For a building that has 1 to 60 building occupant, there must be 7. The door must be 750 wide. For 51 to 110, there must be 850. For 111 to 220 people, there must be 1050 etc. So our time will go off now. If you want us to continue, somebody can do the WhatsApp call. If you don't want us to continue, if you have any question, you can unmute yourself now and ask any question. We have 2 minutes for question and answer. Any question? Any question? If there's no question, we'll end the class. Thank you, ladies and gentlemen. We'll see you on Saturday for the exam. Best of luck. Bye.